This question is to prove trigonometric identities. A step-by-step guide. First, recognize compound angle identities. We begin by rewriting the left-hand side of the equation using angle addition formulas. Cosine of 4x is rewritten as cosine of 2x plus 2x, which becomes cosine squared of 2x minus sine squared of 2x. Then we rewrite cosine of 3x as cosine of 2x plus x, which expands into cosine of 2x times cosine of x, minus sine of 2x times sine of x. Multiplying this by cosine of x gives us cosine of 2x times cosine squared of x, minus sine of 2x times sine of x times cosine of x. Next step is to expand using trigonometric identities. Now we write out all the terms we just described. Cosine of 4x becomes cosine squared of 2x minus sine squared of 2x. The second part, cosine of 3x times cosine of x, becomes cosine of 2x times cosine squared of x, minus sine of 2x times sine of x times cosine of x. So the full expression becomes cosine squared of 2x minus sine squared of 2x minus cosine of 2x times cosine squared of x plus sine of 2x times sine of x times cosine of x. Next step is to use double angle identities. We now substitute standard formulas for double angles. Cosine of 2x is replaced with cosine squared of x minus sine squared of x. Sine of 2x becomes 2 times sine of x times cosine of x. Now let's evaluate each part. Cosine squared of 2x becomes the square of cosine squared of x minus sine squared of x, which equals cosine to the fourth power of x, minus 2 times cosine squared x times sine squared x, plus sine to the fourth power of x. Sine squared of 2x becomes 4 times cosine squared x times sine squared x. Cosine of 2x times cosine squared x becomes cosine to the fourth power of x, minus cosine squared x times sine squared x. Sine of 2x times sine x times cosine x becomes 2 times sine squared x times cosine squared x. Next step is to combine like terms. Now we combine everything together. Start with cosine to the fourth power of x, minus 2 times cosine squared x times sine squared x, plus sine to the fourth power of x. Then subtract 4 times cosine squared x times sine squared x. Next subtract cosine to the fourth power of x, and add cosine squared x times sine squared x. Then finally add 2 times sine squared x times cosine squared x. Now simplify. The cosine to the fourth power terms cancel out. The combined terms give us sine to the fourth power of x, minus 4 times cosine squared x times sine squared x, plus cosine squared x times sine squared x. This simplifies to sine squared x times the sum of sine squared x and cosine squared x, minus 4 times cosine squared x times sine squared x. Because sine squared x plus cosine squared x equals 1, this becomes just sine squared x minus 4 times cosine squared x times sine squared x, which exactly matches the right-hand side of the original identity. The identity is proven. When working with expressions involving multiple angles, always rewrite everything using standard double angle or sum angle formulas first. It helps simplify the problem early on and avoids mistakes later. Watch out for sign errors when expanding squares. Those are easy to miss, but make a big difference. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.